the next. You are going to see both of those kinds of options as you go throughout this test and your honors page. All right, test hint number 10, identify a molecular formula. That would be a molecular formula as opposed to a formula unit for an ionic compound, or something that is the formula for just an element. So CCl4 again, carbon tetrachloride, that is a molecular formula. It's made of all nonmetals. We know that that would be covalently bonded and so on. NaCl, sodium chloride, that is a formula unit for an ionic compound. Cl2 is a molecule, but it's also an element. Those magic 7, we got to treat them differently. They're special consideration, and that is the formula of an element. It is technically not a molecular formula for our purposes here in our classification at this point. Test hint number 11. Describe the energy changes that take place as atoms bond or cause atoms to bond. So we go from a difference between 0 and that of the minimum potential energy. Atoms want to go to a lower energy state when they bond, and that's pretty simple to see from a chart. Take a look at the chart in your book that shows that. You sometimes see a little dip as well. Also look at the simulation. A couple of the simulations that I have posted on Moodle will actually allow you to bring atoms together and look at the changes in energy on those graphs. Okay? Let's see, number 12, test hint number 12. Determine what a specific atom has to do to satisfy the octet rule. Okay, so we're going to ask you about any nonmetal up there, and this is really just, how many electrons does this atom need in order to satisfy the octet rule? So if we ask something like, say, fluorine, that has 7 valence electrons, clearly that just needs to gain 1 more, or share 1 pair of electrons to fill its outer shell, satisfy the octet rule. Something like oxygen, that has 6 valence electrons, well, that's going to need to either gain 2 more electrons or share 2 pairs of electrons in order to satisfy the octet rule. It's really just the difference between how many valence electrons the atom has and 8. Pretty straightforward. Question 13. Compare the electronegativities of atoms within a molecule to their location in the molecule. Okay? The atom in the center tends to be what? The least electronegative atom, the most electronegative atom, the one with the most electrons, fewest electrons. Take a look at this a little bit further in your book. I'm just going to give you a vague hint on this one on purpose. I want you to do a little investigation there. Okay? But I'd also give you a clue that carbon tetrachloride is a real good example of a comparison between the electronegativities of the center atom and the ones on the outside. Question number 14. Explain how to draw a correct Lewis structure. Okay, so this is a general question about drawing Lewis structures in general. And when you draw a Lewis structure, I'll just kind of talk you through it, of course. First thing you're going to do is identify the elements that are involved. Say, for water, we're going to draw H2O. We know there's hydrogens and oxygens. The next thing you're going to do is figure out how many valence electrons each atom has. We know from the periodic table that oxygen has 6 valence electrons. We know that hydrogen has 1. So I've drawn the elements. I've assigned them their correct number of valence electrons. And now the next step is to figure out where they can overlap, where there are half-filled orbitals. Clearly that is here and here. So we got a single bond in 2 places there. That didn't come out very well. And now the last thing I'm going to do is check to make sure that I've satisfied the octet rule, that every atom has 8 valence electrons. So I'm going to count my unshared pairs and my shared pairs on oxygen. I've got 2, 4, 6, 8. So oxygen is fine. And then I've got 2 valence electrons associated with each hydrogen atom. Hydrogen doesn't have to satisfy the octet rule, and yet it does at the same time. Wow, that'd be a great honor stage question also. What does hydrogen do to satisfy the octet rule when it can't possibly get 8? Hydrogen has just that first energy level, that s orbital that can only hold 2 valence electrons, so it acts like it satisfies the octet rule, even though it doesn't have all 8. The other atoms are going to satisfy the octet rule, with a few exceptions here and there. Boron is okay with 6 valence electrons. Sulfur and phosphorus can have 10 and 12 valence electrons. They can go above and beyond the octet rule in some instances. Moving on to question number 15. Identify the number and type of bonds when given a chemical formula. Okay, so if I asked you to show me a Lewis structure that has 2 covalent bonds, well, water's a good example of that. Water has 2 shared pairs of electrons, and it also has 2 unshared pairs. If I asked you about a molecule that has 3 covalent bonds, you might give the example of ammonia, where nitrogen with its 5 valence electrons bonds to 3 hydrogens. We have 3 covalent bonds shown and 1 unshared pair. If I asked you to give an example of a molecule with 4 covalent bonds, you have all sorts of choices. Methane has been our simplest example all the way through in this chapter, showing carbon surrounded by 4 hydrogens, 4 shared pairs of electrons. Be a pretty straightforward question like that. That brings us to question number 16, where the hint says, draw a correct Lewis structure for a given molecule. This will be a very easy molecule, one you've drawn many a time in a couple different labs that we've done. In fact, I think you might be surprised at how easy this example actually is. But this is one of those questions where I give you the pictures as the answer choices, and you have to pick the right one. Remember that when we scramble the versions of the test, the answer choices will be mixed up. So picture A might really be answer choice D. So don't just write down the letter of the picture, make sure you're selecting the correct answer choice. And make sure you're following the octet rule. Test hint number 17. Describe resonance. Well, Terry and friends in the Wiggle 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 video were actually showing you resonance when they were doing this little dance maneuver there. Please don't show anybody that. Resonance is an oscillation, and one very common example of a molecule with a resonance structure is sulfur dioxide. And we're drawing it in the simplest form for anybody else that would happen to watch this on the World Wide Web for I don't know what reason. This is Chem 1, so we're going with the basics here. Sulfur with 6 valence electrons can singly bond to one oxygen atom and doubly bond to another. But it is quite likely that that double bond is between the sulfur and this other oxygen instead of the sulfur and this oxygen. And actually we know from measurements of bond energy and bond length and a whole bunch of other stuff that the double bond oscillates, jumps back and forth between the sulfur and this oxygen and the sulfur and this oxygen. That is an example of a resonance structure. We would draw this molecule 2 different ways. Okay? Both of those representations work for sulfur dioxide as an example of a resonance structure. Test hint number 18. Define molecular compound. Okay? A molecular compound is one that is covalently bonded, all nonmetals, represented by a molecular formula. Very straightforward question. Test hint number 19. Describe how hydrogen bonding affects water molecules. Well, we know all about water. Okay, we've had this molecular model of water, and hang on a second.